Hello all, I am Wesley, working as an assistant professor in the Department of Electronics and Communication Engineering, Kamaraj College of Engineering and Technology. So in this video, I am going to present a topic, robot manipulator kinematics. So robot manipulator kinematics, or we can say robotic arm kinematics. Let us get into the topic. Robotic arm kinematics, or simply kinematics, is the study of motion without considering the involvement of forces. If we consider motion means it may be the position of the robotic arm, or it could be the velocity of the robotic arm, or it may be the orientation of the robotic arm. So I want to introduce some other topics that are relevant to the robot kinematics are, first one, statics. Static is the study of motion with considering the involvement of forces. Another one, dynamics. Dynamics is the study of motion, and also here we consider the involvement of forces and acceleration. So next one, introduction to manipulator kinematics. So we know robot manipulators has two basic elements. They are links and joints. So links are nothing but it's a rigid body that connects the joint. So joints are nothing but it's a connection between two links. So in this diagram, so this one is the link that connects two joints, and this one is the joint 1. It connects two links, that is base link and the link number 1. Each joint represents 1 degree of freedom. Here the joint may involve either linear motion or it may be rotatory motion between the adjacent links. Okay. Generally, kinematics in robotics is fundamentally classified into two types. First one, forward kinematics, and second one, inverse kinematics. Let us discuss each one in detail. So forward kinematics. So here we are converting from joint space to world space. So in forward kinematics, joint space coordinates will be given. Here we are converting joint space to world coordinates. So joint space are nothing but it's a joint parameter that are present internal to the robot, and the world space are nothing but it's a global coordinate system, or we can say it's an XY axis. So in inverse kinematics, we are converting from world space coordinate into joint parameters, or we can say joint space parameters. So in this slide, we are going to derive an expression for the forward kinematics of 2 degrees of freedom arm. So since this is a forward kinematics problem, here joint space is given, that is theta 1 and theta 2 is given, and we have to find the world space x, y. So I have drawn XY axis. So consider this line as link 1 and this line as link 2. So this link 1 is making an axis, making an angle theta 1 with base axis. Here link 2 is making an angle theta 2 with the reference axis. So our job is to find the value of x and y. So here this is an x-axis, this is an y-axis. So according to trigonometry, this length can be found out by L1 sin theta, and this adjacent length can be found out by L1 cos theta 1. Here I am projecting the angle theta 1 such that phi can be written as theta 1 plus theta 2. Similarly, applying trigonometry formulas, this length can be calculated as L2 sine theta 1 plus theta 2, and this length, adjacent length can be determined as L2 cos theta 1 plus theta 2. So this length is equivalent to this length. So this length can be written as L2 sin theta 2. Similarly, to find this length is equal to this length, L2 cos theta 1 plus theta 2. So to find x and y, so we have to find the length of x and the length of y. So with the help of trigonometry formula, we can write as x is equal to L1 cos theta 1 plus L2 cos theta 1 plus theta 2. Similarly, y can be written as y is equal to L1 sin theta 1 plus L2 sin theta 1 plus theta 2. Thank you.